In this video, we are going to demonstrate the peel.CAD module that is available with the new Peel 3D scanner. Now, the standard software that will come with the Peel 3D scanner is called peel.OS. And that will allow you to do your scanning, to clean up the scan data, and you can kind of see the steps right here, to merge the data, to align it, to improve it, and then to export it. And what that's going to give you is a polygon mesh, an STL file. So it's just points converted to polygons. It is not CAD. So if you want to take scan data and then turn it into CAD data, that is an additional step to reverse engineer it. So what we have here, this is a machine part. It was shiny aluminum. We scanned it with the Peel 3D scanner. We didn't use any scanning spray, so overall it looks pretty good. Couple little holes in here, some other things, we'll clean that up in a minute, but overall it looks pretty good. So now that we're done scanning, we're going to walk through the next steps. Now, we're going to show the peel.CAD. We also have a video we made with this exact same part where we used some different reverse engineering software, specifically DesignX Essentials. So if you want to see the workflow, that's a standalone product made by Geomagic. If you just want to compare, you can check out that video. We'll put a link in the description below. Also, if you want to see the entire scanning process and using the Peel 3 scanner, we have a very long, in-depth demo. We'll also link that below. But let's get started, because what's nice about the peel.CAD is it's integrated right with the Peel software. So let's walk through taking this now and then taking it into the peel.CAD. So next thing we're going to do is click the Align tab. Now, we could do this in the peel.CAD, but it's pretty easy to do right here. So we look at the part, we want to put it in a coordinate system, because when you scan it, it's really not in a coordinate system. It's just kind of all over the place. So for example, I'm going to say I want to set my XY plane, and I'm going to just click here on the bottom, because to me that would make sense to put the plane on kind of the major plane. I'm going to flip the normal vector to go up. I'm going to lock that down. And then for my second axis, I think this face would do pretty well. So we'll make that the XY plane, or sorry, the XZ plane. Select that. The vector looks good, and we'll lock it down. So now we're in a coordinate system, so that, you know, a top view, a right view, a side view, etc. is going to look good. Okay. Now we can go to the Improve tab, and if we want to fill some holes and, you know, clean some boundaries and do some smoothing, we can do all that. We really don't need to, even though you can kind of see some different areas in here. You'll see when we get to the reverse engineering process, it really doesn't matter. So now our next step is to go ahead and export it. And what we're going to do, so we have two options. If you don't have the peel.CAD, you would just export a mesh, and that's going to be an STL file. And if you're scanning in color, that's going to be an OBJ file, and that'll include the texture map. We're going to click the peel.CAD button. Okay, so it saved our session for us, so we always have it saved, and we can go back to it. And then it's brought it into peel.CAD. And peel.CAD kind of has its own interface, and we'll get into that. First thing is, let's take a look at our view. So if I went to a Z view, that's a top view, and let's do a Y view. So you can see now our part's in a nice coordinate system. Now, there's a few different kind of methods to modeling. So let's just talk about the process. So what we have here is scan data. What we want is CAD data. So if you take a look at scan data, I'm going to turn the triangle edges on. You can see what this is. It's nothing more than a bunch of little triangles. Now, the software and the scanner is smart enough. You can see when you go around a corner, it's going to tighten up the triangles, and when you're on a flat, it's going to, you know, give you bigger triangles, right? So it's smart enough. You can see it here on this radius. It's basically smart resolution. So it will adjust the triangle size based on the shape. But at the end of the day, this is just, you know, tens of thousands or millions of triangles, okay? So what that means is, you know, in a CAD model, for example, this would be a face, and, you know, these would be cylinders. This would be a plane, you know, this would be a fillet, you know, this would be a cylinder, etc. But there's none of that defined here, okay? If you were to import this into most CAD systems, They really can't work with it. In SolidWorks, it comes in as a graphic entity, and there's very little you can do with it. So we need to build CAD. And what we're going to do is extract geometry from this, and then we're going to take it into a CAD system. Now, I'm running SolidWorks, but this will also work with Inventor and Solid Edge directly. And then indirectly, you can export IGES or step files and take them into any CAD system. But the the transfer button here just makes it a little more convenient. You'll see that here in a minute. So we want to build planes and cylinders and all, normal CAD geometry. And this part is not that complicated, but still it's going to take a little bit of time to turn it into CAD. So let's kind of get started, and we'll explain this more. Now, there's a few ways. Let's walk through the menus first. So first, here's your alignment tools. Now, we don't need them, or we're not going to use them because we already did it in the peel.OS, but they are here if you want to use them. And then these are your creation tools. This is where you can build geometry, spheres, cylinders, lines, points, cut cross sections, drive a center line down a pipe. Then we can do some basic measuring. We can do some basic surfacing. This is just manipulating. This is cleaning up the mesh, filling holes and things like that, and organizing it better. And then you've got all these other tools, smoothing. Then you've got some basic, offsetting. So these are kind of all the mesh tools. Now, since we're going to build CAD, it's a sketch-driven solid model. We really don't have to clean the mesh up, even if there's holes in it. Even if the data isn't perfect in some areas like you see here, it's not going to matter, and you'll see why, okay? So to get started, you really want to think about, well, how would you model this in your CAD system? Well, I would start with kind of the major feature, which is this bottom plate kind of shape here, right? And so where would I start drawing that? Well, I would probably start from the bottom. So what I'm going to do is I'm going to fit a plane. And when I click plane, it automatically clicks the right selection tool based on, what you pick here. So for example, for a plane, it's going to click the similar normal, meaning I'm going to click somewhere on the part, and it's going to find all the triangles that you see here in yellow that are pretty similar in their normal direction. And it's going to fit a plane through there, okay? And we can also constrain that. I don't really need to here because that's the same plane I used to put this in a coordinate system. So I'll just hit OK. So that's identified the bottom of the part with a planar entity. So let's go over here to our modeling tree. And you can see there's the original alignment. And then you can see there's that plane. So as we create these CAD entities, which a plane is a CAD entity, they will start showing up in the list. Okay. So that'll define the bottom of the part. The next one I'll want to define is the top of the part. So I'm going to do the same command again, and I'm going to pick the top. Now, the only issue is, how do I know that those two are parallel? Okay, I don't. So because, this top plane could be a little bit off, and very typical in the manufacturing of parts, things just aren't perfect, or this part's worn out, or it wasn't machined right to begin with. So I can click be normal to, and I'm going to pick plane 1. And if you looked, you can notice that plane changed, right? So now it is locked in to be parallel to plane 1. And I'm going to say, okay. So that has identified the top and the bottom of this major feature, okay? Now what I'm going to do is cut a cross section through here, okay? And in Geomagic Design X, they refer to it as a mesh sketch. It's essentially the same thing. So my initial plane is going to be plane 1. And then it's going to give me this little coordinate system, and I'm going to slide that up. Now, this is a machine part, so I can kind of go anywhere because it's straight walled. If it was a plastic part, I'd want to be careful because it's typically going to have draft. So I'm going to cut that section right through the center, and you can see there's this white line that goes all the way around the part. That is a profile or a section through the data, and I'm going to hit OK. Okay. Now, I can continue and keep extracting more data and do all of it at once. But to keep things simple, I'm going to go ahead and stop at this point and start building real CAD. And we're going to do that in our CAD system. So typically the workflow with any kind of sketch-driven part is extract information, take that into your CAD system and build real CAD entities. So I'm going to pick these three, and I'm going to say transfer to SolidWorks. Now, I've already got SolidWorks open. If it's not open, it will open it for you, and then it'll bring in these parts or bring in this data. So if I rotate this, you can see what we have. We have the top plane, and it has the same names as in the peel.CAD, the bottom plane, which is plane 1, and then our cross section. Now, the cross section can be a polyline or a spline. I believe the default was spline. It's really not going to matter. You're going to see here in a minute. Okay, so here we are in SolidWorks, and let's take a look at what we have. So you can see we have plane 1 and plane 2, and you can see it retains the names. They're over here in the history tree. And then we have our cross section, which is just comes in as either a spline or a polyline. And you can see what a polyline is. It's just a bunch of points. It is not a traditional line or arc. And that's, some of the geometry we're going to want to build. So, and also full disclosure, I'm a SolidWorks novice, so there may be better, faster ways to do some of this, but hopefully you'll get the general idea. Okay, so let's go ahead and hide that top plane, plane 2. Oops, I hit plane 1. Let's turn that back on. Let's hide plane 2 for right now. And we're going to want to start sketching in SolidWorks. So I go over to my sketch command. I'm going to pick plane 1, which we, of course, know is the bottom of our part. And anytime I'm designing something, we want to take a look at, what's the most important features on this, this particular part of the model. And typically when you see holes, those are going to be important. And typically when holes are designed, they're usually in some kind of pattern. So that's going to be our first thing, is designing or really building the holes and dimensionally making sure they're correct, and then building the other geometry around it. Okay, so to start, let's go ahead. I'm also going to hide plane 1 now. I don't need to see that. And I'm going to go and just do a circle. And I'm just going to kind of, for now, just eyeball it in the center. And I'm just going to make it bigger. I don't want to snap to it, because then I'm going to get like a coincidence parameter constraint, which I don't want. Okay, and I'm going to make that. And then let's go ahead and throw a dimension on it. It's going to work in inches. Doesn't really matter. So we've got our first circle. We've got it, and I'm going to make some assumptions, or maybe I'm going to change the size of it. It doesn't matter, but I definitely want to dimensionally drive it. And I've just kind of centered it on there. So now let's go ahead and make our next circle. And this one, I just want to make sure horizontally I'm lined up. And this time I'm just going to make it bigger. And then in this case, I'm going to vertically align it and make it a little bigger. And in this case, I'm going to align it in both directions. Okay. So now that we've got that, now I can pick these 3 circles here and then double click on our main circle. And I'm going to add a equal radius and hit OK. So now, as you know, in most of these parametrically driven systems, if I change the 10, it'll update all of them. Okay. But you can see these holes, they're not the same size by any stretch. They're all kind of different sizes, and they weren't lined up well. This gets back to the design intent. What would, if I were designing this from scratch, I would want them lined up, and I would want them all to be the same size. And of course, I would want them to be circles. Okay. So now let's do the outer circle, and we're going to essentially do the same thing. I'm going to draw it. I'm going to draw it a little bigger to start with. I'm going to throw a dimension on here. Let's try 25, which would be about an inch. And I'll say, hey, that looks pretty good. And we made it concentric, right? Because we're going to want to make this concentric to this circle here. But again, you can see how far off this is. And, maybe a lot of this doesn't really matter, but we certainly want the part to look good. So again, we'll do the same thing here. Throw one there, throw one there, throw one there, and there. Okay. And let's pick this one, this one. Oops, I got them in a different command. Let's try that again. Here, here, here. And again, we'll go equal. Okay. So you can see now everything is concentric. Everything's in a nice pattern. And now we just kind of need to fill in the blanks, so to speak. Now to do this, I'm going to first hide this cross section because I basically, it's the tangent at the top here, and then, kind of probably driven down the center here. So I'm just going to hide this. And then I'm going to come in and create a line starting at that tangent C over to that one. And then we'll do the same here and here. And then I'm going to drive the center of this circle and that circle. And then do the same here. So if we turn back on our cross section, you can pretty much see. And then the fillet will add after we turn it into a solid body. So now we're ready to go ahead and trim this all up to complete our sketch. We're going to use the trim entities command. There are many ways to do this. I'm just going to use trim closest and just pick all the pieces that I don't want remaining, so we have a nice and close sketch. Okay, so we have our sketch done here. Now you could also dimension, the center from this hole to this hole and these sides if you want. For time, I won't, but you get the basic idea here. So now we're going to want to go ahead and extrude it up. And actually, before we do that, let's turn on our planes here so we can just see them. We're going to want to see plane 2 and plane 1 just for reference. So let's go ahead now and extrude it. So we're at the bottom here, and instead of going blind, let's go up to surface, and that was part of the reason why we created that second surface or that second plane, so we just know where the top of the part is. We could certainly go blind and key in a value, but since we were able to extract that right from the CAD, you can see. So now you can see there's our first feature. Now let's go ahead and hide the planes again, and I'll just throw these fillets in here in these corners. Yeah, and yes, you could do this in the sketch. It really doesn't matter. I'll just do them here, and more than likely they're aesthetic. And let's try 12 and see how that looks. Okay, so we'll fill that in. And if we look from the top and turn back on our cross section, you can see what we have. So there's our first solid body. Okay. And, as we discussed, we fixed everything in the sense of good design intent, made everything out of lines and arcs and circles. Okay. So that's our first real kind of feature driven off those sketches. So now we can go back into the peel.CAD and start looking at, okay, what do we want to do next? Well, if we look at this, we've kind of got two other major profiles, this way here and this way here. Does it matter where we start? Maybe not. I'm gonna take this profile going this way. So to do that, I'm going to go back and extract a plane. And when I extract this plane, I'm going to want to make sure it's perpendicular to these planes because, this thing could be on a slight angle and not quite be perpendicular. So I'm going to click perpendicular axis and we will click plane 1. Okay. And you can see it moved again. So that's going to lock it in so that it's perpendicular. So that gives me that face. Then I'm going to want this thickness here. So we'll go ahead and pick this face. And this one we will want normal. I guess we could do that perpendicular as well. We will want normal to plane 3. And again, you'll see it slightly adjust. Okay. So that'll give us the thickness. And then this appears to be another plane here. So we'll go ahead and pick that. Now that one, oops, hang on here. I think I got something else selected. Pick plane and pick that. There we go. Okay. And you can see that's on an angle. Obviously it's on an angle, so we'll take it as is. And then we're going to want a cross section through here. I mean, we could pick a plane here and pick a plane here and then pick, a plane here and a plane here. Or what I'm going to do, which I think is faster, is going to be select this, and we're going to take that through plane 3. And we're going to drag it right kind of in the middle up here so we get that, that full profile. We're going to take that right there. Okay. And then for this cutout, same thing again. We're going to need to get this shape here. So to do that, I'm going to take another cross section. Okay. And that'll also be through plane 3. But this time, I'm going to drag it. And I want to get so that I'm at the bottom of this radius here, right? So I'm going to pull it out. Okay, so that'll give me the angle this way. That'll give me the bottom. Let's pull this around and give me that side, okay? And it's going to end up getting clipped off on this plane. So as long as I'm catching it here at the bottom, that'll give me this shape there. This first section will give us that slot and that circle. And I think that's going to be everything. This plane here will intersect that plane to give us this piece. So I think that's going to be everything we need. Okay. So let's go back. And for now, let's hide the first 3. We don't need to see those. Okay. So you can see what we have. We have this face, a section through the whole part, and then a section for this slot here. And then we have this face here. So I think that's everything we now need to define our next set of our next feature. So we'll pick plane 3 through cross section 3, and we will transfer to Solidworks. So if we come back here in Solidworks, you can see what we have, right? So we still have our solid body, and now we have those new entities that we can start modeling from. Okay, so like before, what is going to be our process? Well, I think that we're going to start with this main feature here, extrude it out, and then we've got to cut it off, but the cut's going to be a little fancy. We'll get to that here in a minute. Let's start and just start working on that plane. So to do that, we're going to go back again to our sketches. We're going to pick this plane here. And then again, I like to hide all this stuff. And let's go ahead and hide the other cross section. We don't need to see that right now. Oops. That is cross section. There we go. Okay. All right. Now you can see here we've got a difference. Again, just this part is not a very good clean part, so we'll want to take that into consideration. But let's just start and let's just draw some lines. And I'm just going to pick like here and here. And, the way I sketch in here is really no different than in any other reverse engineering tool. If you've seen some of our other videos, I stay away from the corners, and then I'll define those corners, okay? So we'll do that. Now down here, we're going to want to, in this case, grab this corner here. Now, how am I going to do that? Well, one of the ways would be to convert an entity and grab that, okay? Because that's going to give me that point to snap to right there. And then I'm just going to bring it up close here and snap, okay? So if we want everything consistent and everything to line up as we model this, that's a good way to do it, okay? And there. And let's get our top. And you can see this top, when I made it horizontal, we can see the part is not horizontal. Okay. And then we have our circle here. and I'm just going to make it bigger, and then I'll come back and throw a dimension on it. Let's try 12. Okay. And then try to move it into place. Okay. Might be 11, but good enough for this. Okay. So let's start with this, and then we've also got this slot here. You can see the scan data is a little bit rough in this, and I'm just going to, for time, I'm just going to make this and that, and then we'll run this out. I'll just run it up, make that vertical and tangent, and then we'll trim it all up. All right, so let's start trimming up some of this. So let's see here. I think corner would work. No, we don't want that. We want to trim away inside. I'm not real good at some of these. We'll just do it this way. There we go. And then this one we're going to make the corner. I don't make the real small radiuses. We can always add them in once it's a solid body. I don't like to have a lot of those small radiuses in my sketch. Okay. Theoretically, I could put the bigger ones in, but again, I'll do that in the solid body. And let's see if I can get this to trim to that. That should already be there. Okay. So there we go. There is our second sketch. All right, so now we're ready to go ahead and extrude that sketch. And so what I'm going to do is I'm going to come in here and I'm going to pick this. Now, ideally, and we're going to flip directions. Ideally, we would just extrude up to this plane here, but we know we've got that little notch going up here. So you can't, when you extrude to a surface, you can't pick two surfaces. So I'm going to have to do this in two steps. And to start with, I'm going to drag it so it goes beyond the bottom here. And we are not going to merge the results yet. And then I'm going to hit OK. Now to trim it, I need something that intersects this plane and this plane. Now I could go in and try to build a sketch just in SolidWorks, or I'm going to jump back into the peel.CAD software. peel.CAD software. And I'm going to cut a section because I think that now that I'm looking at it, it might be the easiest way to do that. So let's start by creating, I'm going to need a plane on this side, and I don't think I've built one over here yet. So we'll go ahead and create a plane here on this side, and we will make sure it's perpendicular to plane 1. Say OK. And let's select cross section. This will be plane 6. And we're going to slide this guy in. And I need it where it intersects this base and this face. So I want it about right there. I think will work. We'll hit OK. And then we're going to pick that and take that into SolidWorks. Okay, so here we are back in SolidWorks with this new section. And what we're going to want to do is create a sketch. We'll go ahead and just create it on the front plane. And what we're going to want to do is create a line starting here. And we're just going to go down beyond the part somewhere. And same thing, we're going to go in this direction and just above the part. And then we'll trim that with a corner trim. Do that again. Pick here and there. That'll give us what we need. So now I've got a line that represents that kind of that shape. Then we'll go to Insert Surface, Extrude. And we'll go in both directions. It doesn't really matter how big it is as long as it's beyond the part. Okay. And then let's bring back this one, and we can go ahead and hide that one. So we're going to want to trim that off to that shape. So we'll come under here. And we're going to go cut with surface. We're going to pick that surface and then this body. Flip the direction. There we go. Okay, so if we now hide that surface, okay, and let's bring back the bottom boss. Okay, so there you go. So we've got that shape. So I think that might be an easier way to do it. We'll merge these two together later. And now we have that next cutout. But you can see the process, and then we'll put in the fillets. So let's go on and create that next shape. Okay, so next up is that slot right in there. So let's do this. Let's hide this plane for right now. Okay. All right, so back to sketch. Pick this cross section, and we're going to build this profile. So let's go and we will make this one a closed sketch. So it's a solid body because we're going to want to extrude it to the face. This again will make sense. So again, I'm just going to go up larger. Now, probably the proper way to do this would be to find the center and mirror it over um, so that our angles are the same. But for time, we'll just keep this simple. Close that up. And then finally, we'll draw the bottom. We'll just make sure that's horizontal. And then we'll trim that corner. And again, I will put in all the fillets at the end. Okay. So that should represent our slot. So there we go. And we can exit out. And let's bring back primarily this right there. Okay. So now we are going to do a extrude cut. We're going to pick this. And we're going to go up to surface, and we're going to pick that surface there. And direction 2 will be blind, and we can go something smaller than that. Let's go 15. Okay. And let's go a little bit more. Let's go like 20. Okay. And let's hit OK. There we go. So that should give us exactly what we need in there. It looks like when we extruded that, I forgot to include the hole in our selection, which I'll go back and do. And so you're getting the idea here, right? So it's bringing stuff back and forth, looking at the scan data. So we've cut out that. I'll go back and fix the circle. We have those. We'll boolean these together. We've got a couple little cutouts here, but and then just all the fillets. So we're essentially done at this point with all the major surfaces and cuts. So we'll come back here. We'll add that one. That'll give us our hole that we forgot to select. And there we just combined our two solid bodies together. And now we can start adding in our fillets. This one down in the bottom is the largest. Oops, that's too large. Let's fix that. Let's try 10. And then the ones on the sides are smaller. Let's go like 3. Okay. And then the only other thing is we need just a cutout for, I think it's just room for the bolts um, right here, which is just, easily done. But other than that, I think we've got pretty much everything. So you can see, this part's a little trickier than it first appears. It does got some shape to it. But what do we end up with here in SolidWorks is a feature-based solid model with all the, everything, and it properly designed, okay, so that the holes are in a pattern, everything is concentric, everything is parallel, everything is perpendicular, everything is or can be dimensionally driven. But that just kind of shows the workflow to go from peel.CAD into a product like SolidWorks, Inventor, really any 3D CAD. The only advantage to these three is you just push a button. With a different CAD system, you would select it, you would write click selected entities, and then you would pick IJStep or DXF. That's really for just like lines. So it's just a little more automated going to these three systems. These are all Parasolid based systems, so that makes it easy. But that's the general process. So 3D scan, extract geometry off of the scan data here, and then into your CAD system, and then start building. So if you'd like to learn more about the Peel 3 3D scanner or the peel.CAD reverse engineering module, feel free to give us a call at 877-845-2700, or you can send us an email at info@ems3d.com. Or finally, in the description below, there is a link to a quick contact form. You can fill that out, and we can get in touch with you and understand what it is you're trying to do and put together the right combination of scanner and software so that you can 3D scan parts and turn them into CAD models.